Okay, we're focusing on our last of the special forms that I wanted to talk about, which is the sum and difference of cubes. And I've separated it into the two formulas instead of showing it in one line like I did in the first video. So here's the sum of cubes, a cubed plus b cubed factors to that business right there. And here is the difference of cubes, which factors into that you see on the right. Now, what I want to do is, first of all, check to see if this is legitimate. And I'll check one case. I leave it to you to check another case. And then I'll give you a little, some examples and a little acronym that might help you memorize what this formula looks like. So first, let's do the check to make sure we are living in reality here. What am I checking? I'm going to multiply a plus b times a squared minus ab plus b squared. So what I'm checking is that first formula, the sum of cubes. So here's the normal way to do that. A gets multiplied by all of those terms, and then b gets multiplied by all those terms. And we'll see how all of this turns out. So what we get at first is a times all those things gives me a cubed minus a squared b plus ab squared. Then I multiply b times all these guys. And b times a squared, that gives me plus ba squared. I'm going to put that as plus a squared b right below this one. ba squared b is the same thing. The next one is minus ab squared, so I'm going to put minus ab squared right there. And the last one is plus b cubed. Okay. Whenever I have a lot of terms that I'm getting from multiplication, I kind of like to line them up. That is, line up the like terms at least, so that I can add it all up right away in a nice orderly fashion. And what you can see here is that we get a cubed minus a squared b plus a squared b adds up to 0, plus ab squared minus ab squared adds up to 0, and all we're left with is plus b cubed in the end. So indeed, that one checks out. Now, how can you possibly memorize those formulas? Well, some people have wonderful memories, some don't. I don't have the best memory, and so I like to remember my soap. What am I talking about with soap? This symbol is the same. This one is the opposite. And that one is always positive. And so there's the soap. Same, opposite, always positive. Same as what? Same as the original symbol here in the difference or the sum of cubes, whichever one you're talking about. And if you follow that pattern, same, opposite, always positive, you'll get the right formula for either of these. So that being shown and at least one of them checked, let's take a look at a few examples. So suppose we had x cubed plus 8. Now, of course, it's helpful to know a few of your cubes off the top of your head when you're messing with the sum and the difference of cubes. For example, what cubed gives me 8? Well, it turns out that 2 cubed gives me 8. So I can say b is equal to 2. Of course, a is equal to x because x cubed gives me x cubed. Which means I can factor this into, following the form here, x plus 2, there's the same, x squared, minus, there's the opposite sign. And this part is really easy because all you have to do is multiply these two guys in the binomial. So it's just 2x. There's my AB. Always positive, plus this guy squared, which is 4. And that's it. X plus 2 times the trinomial x squared minus 2x plus 4. Now you might be asking, why don't we factor that trinomial? And it turns out that this is guaranteed to be prime, okay? So any trinomial having this form where you only have AB in the middle, turns out that that thing is not further factorable. It is prime. If you had a 2 there, then you've got a perfect square trinomial. But we don't have that case. Let's take a look at another one. How about 27x cubed minus 64 y cubed. You have a difference. Is it a difference of squares? No, because these two guys are cubed. Is it a difference of cubes? Maybe. But we need to determine whether 27 is something cubed and 64 is something cubed. And it turns out both of them are something cubed. 3 cubed is 27. 4 cubed is 64. So this comes out to, I'll use blue now, 3x. I'm going to use the minus sign. 4y. Those are the two things that are cubed to give these to you, but now I need the remaining trinomial. Square the first thing, 9x squared. Change the sign. Multiply these two guys together without the sign to give me 12xy, and then always positive. This guy squared is 16y squared. And that's it. Here's my signs. Let's check that. Same, opposite, always positive. And if you remultiplied it through, that's the real way to check. See if that comes out to what you started with. Let me give just one more example for this sum and difference of cubes. I don't want to go too deep into this, save simply using the formulas. Suppose we had something like this, 2x cubed minus 16. So again, we've got a difference. Is it a difference of squares? No, because that's not a square. Is it a difference of cubes? Well, 2 is not a cube. Neither is 16. However, don't forget, factor the greatest common factor first. Always factor the greatest common factor first, and there is one. 2. Not 2 greatest common factors. The greatest common factor is 2. So we're going to take out 2, and what we're left with is x cubed minus 8. Now do we have a difference of cubes? Yes, we do. Here's x cubed. This one, 2 cubed, is 8. So I'm going to take that, keep your greatest common factor, and then start applying the appropriate formula. This has a minus here, so we're looking at the minus case, which gives x minus 2 times, here's the trinomial part, x squared plus 2x plus 4, and that's it. Here's our greatest common factor out front. No matter which method you're using, what you're factoring, always remember, factor the greatest common factor first. And that is it for factoring special forms.